开始了。
Cool.
All right. So last time we delved into the generative agent paper. Uh, I think we went through about 1/4 of it. We stopped at exactly at how the overall architecture, if I remember correctly.
Yeah, something like that. Maybe the first few pages.
Ooh, AI assistant. Sorry, I got distracted.
Everything's AI enabled now.
Okay. Environmental interaction. This is a did we go through this last time?
I think we stopped at day in life.
Staying life.
Yeah.
I want to revisit environmental interaction because I feel it's kind of very relevant to what we're doing.
Yep.
I'm just gonna read it through. Okay.
Okay.
Smallville features the common affordances of a small village. I remember reading this already, including cafe, bar, park, school, dorm, houses, and stores. It also defines sub areas and objects that make those special spaces functional, such as a kitchen in a house and a stove in the kitchen. All spaces serving an age as agents' primary living quarters featured a bed, desk, closet, shelf, as well as a bathroom and a kitchen. That's super elaborate. Agents move around Smallville as one would in a simple video game, entering and leaving building, navigating its map, and approaching other agents. Agent movements are directed by the generative agent architecture and the sandbox game engine. When the model dictates that the agent will move to a location, we calculate a walking path to the destination. Okay, this is our answer right there. Um, Model dictates move somewhere. It's just kind of rough, like kind of object oriented mostly. And then there's an engine that actually kind of executes it. Okay. Uh, in addition, user can also enter the sandbox world of Smallville as an agent operating within it. The agent that the user embodies can be an agent already present in the world, such as Isabella and John, who can be outside visitors. I think we went through this. User and agent can influence the state of the objects in this world, much like sandbox games such as The Sims. For example, a bed can be occupied when agent is sleeping, and a refrigerator can be empty when agent used up the ingredients to make breakfast. End users can also reshape an agent's environment in Smallville by rewriting the status objects surrounding the agent in natural language. Huh. For instance, yeah, I think we went through this. You can interfere as God mode, as God by playing God, and just randomly say it's burning, or in you could I think you can even do something outrageous like a UFO flies over
Yeah.
and just suck your stove out like into the midair or something like that. It's all compatible. I think that's the appeal of this kind of new type of game because it's not limited, it's not restricted.
Yep.
Okay, example day in the life. Starting with a single paragraph description, generative agents begin planning their days. As time passes in the sandbox world, their behavior evolves as these agents interact with each other and the world, building memories and relationships and coordinating joint activities. Okay, here's a demonstration in the link. Oh, okay, so Eddie is the daddy. Wait, who is the daddy? Oh, Eddie is the daddy. John is the musician. To be wannabe. John talks to Eddie about a new piece of music work he is working on. And May, the sister, later comes in and talks to the dad to John. Oh, who is working on the music? Eddie's working on the music. Oh, Daddy is working on the music. Okay, he's working on a piece of music, and then the 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 children start talking about Daddy's work. Okay, kind of transitive nature of this kind of conversation. Knowledge transfers, emergent social behavior, information diffusion. Uh, yeah, we went through that last time about mayoral election. Here's I think a little more detailed look. Brushes teeth, taking a shower, and eating breakfast. Briefly catches up with his wife, May. Oh, he, May is his wife. It's not his sibling. And song. Wait, what? I'm so confused. Sorry. Eddie is the son. John is the dad. And May is the wife. Okay. Eddie's the son. Eddie's not the dad. Okay, relationship memory. Agents in Smallville form a new relationship over time and remember their interaction with their other agents. For example, at the start, Sam does not know LaToya Williams. When taking a walk in Johnson Park, Sam runs into LaToya and they introduce themselves. LaToya mentions that she is working on a photography project. I'm here to take some photos for a project I'm working on. In a later interaction, Sam's interaction with LaToya indicates a memory of that interaction as he asks, "Hi LaToya, how's your project going?" And she replies, "Hi Sam, it's going well." Coordination. Generative agents coordinate with each other. Isabella Rodriguez at Hops Cafe is initialized with an intent to plan a Valentine's Day party from 5 to 7 p.m. on February the 14th. From this seed, the agent proceeds to invite friends and customers when she sees them at Hops Cafe or elsewhere. Isabella then spends the afternoon of the 13th decorating the cafe for the occasion. Maria, a frequent customer and close friend of Isabella's, arrives at the cafe. So let's take a moment back. Isabella plans to throw a party on February 14th. What drives her to start preparing on the 13th? Like, what are the necessary ingredients for that to actually happen?
You mean like why do they understand they have to prepare one day in advance?
Yes, what's the necessary, I guess technically, what's the necessary condition? Like, uh, as we well, like now we got a understanding of how this thing work.
Yeah.
At the very beginning, I think it's at least it got into her planning session at the beginning of the day, in the least. I think on the planning session at the beginning of the day, she knows, okay, I gotta prepare for the party because tomorrow is the party, so I gotta
Okay.
prepare ahead. So I think it started off. I think it started off in the planning, but what triggered the planning is from memory, the past conversation memory. I think maybe summary of the what happened to her
Okay.
yesterday and the day before. Maybe does that make sense?
So you're assuming this intent came from past conversations?
It must come from past conversation.
Okay. Yeah, I guess it could be. Or some sort of common sense that you have to buy supplies in advance.
Okay, how is she aware? Like, okay, does it make sense that it comes from the planning, this fact that she ended up at the cafe preparing for the party a day
Sure,
prior
that makes
comes from
sense.
planning. So planning comes from, I think, like it's sort of like overwhelming sense or overwhelming information about her intent to throw a party in a way.
Okay.
Maybe actually even involves, I guess, she in her mind confirming that okay, everybody's coming, so I'm planning because she probably have had multiple conversations before,
Yeah.
and the fact that the planning takes into account those facts means when you prompt the engine to do the planning,
Okay.
those elements are all in the prompt. The fact that she wants to throw the
Great.
party, the fact that she talked to people, maybe the fact that it feels that everybody's interested, the fact that this and that, everything that has happened to in the past
Mhm.
culminated to the point where she's like, okay, I gotta start planning the party on the 13th.
Yeah,
I
yeah,
think.
I think that makes sense.
Uh oh, actually, you know what? I think instead of just talking, they have a website like where you can replay everything.
Oh, okay.
I think. Okay, let me try to find it. Where is that website? I'm trying to find it. Active thread. Yeah, this is the one. This is the one. So if I fast forward all the way to the February the wait, hold on. It's already February the 13th. Okay, let me try to find Isabella. Did she say Isabella? Did it
Isabella
mention Isabella?
Rodriguez or something?
Okay. Isabella then spent the afternoon of the 13th decorating the cafe. Afternoon, okay. So it's 6 a.m. Okay, in the morning on the 13th. Where is Isabella? This is Isabella. What
Mhm.
is waking up and completing her morning routine, brushing teeth. Wow, you can you can see stay deep. Wow, this is cool. This is what we need actually. What's all these like daily requirements? Wow, this is so detailed. Agents memory events. Holy cow. Okay, let's take a closer look. Okay. Personality, lifestyle, tendency, learned. Wait, what is that? Innate tendency, learned tendency. This is matching the paper.
Oh,
Currently, okay, currently, lifestyle. Isabella is a cafe owner who loves to make people feel welcome. She is always looking for ways to make the cafe a place where people can come to relax and enjoy themselves. Okay, current state, wake up at 6 a.m., be at a cafe at A in the morning, keep working at a cafe at 12. What is this? Come back. Oh, this is our planning.
daily requirements. Uh, Not sure if this is planning or not.
Come back to the Cops Cafe at 2 p.m. and get ready for the Valentine's Day party. Okay, she already has this on the 13th. She already has that. This is our plan. Okay, let me check the. Okay, sleeping, wake up, and completing her morning routine, brush teeth, take a shower, getting dressed, make a breakfast. I think these are like game engine triggered.
Yeah.
Working at a Hubs Cafe uh, while eating lunch, working daily schedule. Oh, this is her daily schedule. Finish decorating the cafe. Oh, this is the whole history of
Oh.
Isabella Rodriguez current time. Wait, how come it's already 8 o'clock in the evening?
Uh,
Something's not right. Okay. Let me let me check her memory. Okay. Getting ready for bed. Bed is being slept in. Desk is idle. Bed is idle. Closet is idle. Refrigerator is idle. So they all have a state called idle. Taking a break. Wait, this is okay. This is like sorted in the reverse order.
yep.
So if I go all the way back in the morning, bed is idle. Go to bed, taking orders, doing this, doing that, behind the cafe, and then Sam Moore is conversing, and she is aware that Sam Moore is conversing with John Ling. Maybe they're in the same room. She overhears the conversation. Then Isabella talks about Valentine's Day's party, and then Sam Moore. Wait, what?
So there are repetitions, seems like.
Well, this is Sam
It's
Moore talks about stuff.
mm,
Isabella talk. I
oh,
think I think they're in a conversation. Isabella speaks. Yeah, it's the time is very close to each other. Like, it happens at the same time. Then Sam Moore talks, and some more states, and then 7 minutes later, Sam Moore talks, and Sam Moore. I think Sam Moore probably was in the cafe and just keeps
yeah.
talking to people. Probably that's what's happening. Sam Moore is checking his email. Yeah, Sam Moore just hangs around in the cafe, and Isabella is aware of the fact that Sam Moore is around. And then all the way 13. But I think by the time by the 13th, Isabella already sort of she wants the plan for the party. So
Okay.
what triggers her is when did she start preparing for the party? Still conversing. Then
They've already started mentioning about Valentine's Day.
yeah, conversing. Isabella reaching ideas, researching ideas. Okay, creating the budget, creating a timeline, checklist, ideas. Jeez. Is a making she started working at 2, I think exactly. That's her schedule, her plan.
Okay.
That was her plan. I think I read it like start preparing for the party at 2 p.m. in the afternoon. Exactly at 2 p.m. she started doing all this stuff. Creating a checklist, researching ideas, and then they all talk about party. Party is all they talk about. Oh, and okay, some other topics, mathematical patterns in nature with local artists, and they keep talking. This is crazy. Okay, but then let's keep playing this. Okay, Isabella Rodriguez, there she is. There she is, brushing her teeth, doing morning routine, and then she goes here, change clothes, Yeah, we still don't know how they plan the thing, but it's kind of amazing to see this. Should we keep
Sure.
going? Should we keep going?
Yeah.
Okay, let's keep reading the paper. Oh, I mean, should we keep reading the paper? That's what I mean.
Yeah.
Okay. 5 agents on Valentine's Day. 5 agents, including Klaus and Maria, show up at Hop's Cafe at 5, and they enjoy the festivities. In this scenario, the end user only set Isabella's initial intent to throw a party, and Maria's crush on Klaus. Wow. How is this possible? Like, how?
Interesting.
Yeah, you see, that's what I mean. Like, we now have local LLMs smarter than GPT 3.5. We got to do better than this. That's our goal.
Right. So how long is this whole thing? Like this whole story, it ended on Valentine's Day. When did it start?
How long did the whole thing pan out?
Yeah.
I'm not sure. Maybe it starts at the 13th. I don't know.
Oh.
Yeah, maybe they cheated a little. I don't know. Maybe it didn't start at 12. I'm not sure.
Okay.
I'm not sure. Okay. Generative agent architecture. Generative agent aim to provide a framework for behavior in an open world, one that can engage in interactions with other agents and reach to changes in the environment. Generative agents take their current environment and the past experiences as input and generate behavior as output. Underlying this behavior is a novel agent architecture that combines a large language model. Blah. Without these mechanisms, large language model can output behavior, but the resulting agents may not react based on the agent's past experiences, may not make important inferences, and may not maintain long-term coherence. The whole point of this paper is memory, summarize memory. RAG, kind of. Challenge it with long-term planning and coherent remain even with today's most performant models such as GPT-4. Yeah, sure. At the center of our architecture is the memory stream, a database. Okay, I think we've already read this.
Mm-hmm.
Memory challenge. Did we read this last time?
No.
Okay. Creating generative agent that can simulate human behavior requires reasoning about a set of experiences that is far larger than what should be described in the prompt, as the full memory stream can context window problem. Consider. Okay, we understand the problem. I'm going to skip that. The memory stream maintains a comprehensive record of the agent's experience. A list of memory objects, where each object contains a natural language description, a creation timestamp, and a most recent access timestamp. The most basic element of the memory stream is observation, which is an event directly perceived by the agent. Common observations include behavior performed by the agent themselves. Okay, a stream of events. Who did what? What happened? Or behaviors that the agent perceived being performed by other agents or non-agent objects. All right, for instance, Isabella Rodriguez, who works at the coffee shop, might accrue the following observation over time. Isabella Rodriguez is setting out the pastries. Maria Lopez is studying for a chemistry test while drinking coffee. What we saw, okay, her memory. Like that, this, is her complete memory.
Hmm.
This. Then you have a RAG problem. Our architecture implements a retrieval function that takes the agent's current situations and inputs and returns a subset of the memory stream to pass on to the language model. Subsets. Okay. There are many possible implementations of a retrieval function depending on what is important for the agent to consider when deciding. Okay, they just have a RAG, long-term memory RAG. Okay. Okay, in our context, we focus on three main components that together produce effective results. Okay, it's a weighted score. The ranking score is the weighted score of recency, importance. Okay, recency assigns a higher score to memory objects that were recently accessed so that events from a moment ago or this moment are likely to remain in the agent's attentional sphere. What just happened? Number one, okay. In our implementation, we treat recency as an exponential decay function over the number of sandbox game hours since the memory was later retrieved. Decay factor is 0.995. Importance, I think important, they just use keyword matching or something like that.
Okay.
TF, IDF, and all that. A higher score of memory objects that agent believes to be important, for example. Oh, actually, no. Wow, this is quite a lot of computation. They actually ask LLM to rate it.
I see. Okay, okay.
Then we can't do that.
Wait, so this happens every 5 seconds?
Well, first off, they don't. Their stuff is not real time. They can compute for as long as they want.
True.
So, but the thing is though, given a moment like current moment, it's not possible for them to compute the current moment against all the past history. It's computationally intractable. So, okay, let's read it. A mundane event such as eating breakfast in one's room would yield a low importance score, whereas a breakup with one's significant other would yield a high score. There are many possible implementations of an importance score. We find that directly asking the language model to output an integer score is effective. Yeah, but that's a hell lot of computation. The full prompt appears below. Okay. 1 is purely mundane, 10 is extremely poignant. Oh, so this is computed like before the fact.
So you mean like when the memory is generated?
Yeah, it's just like universal importance score, like how important this event is to the person brushing. Well, if you have already sort of, based on memory, given memory, and this current event.
I wonder though, maybe they were trying to extract a couple relevant memories and then apply the scores.
Oh yeah, you're right. I remember. Yep, you're right. That's RAG. This is RAG. Oh my god. The prompt returns the integer value 2 for cleaning up the room and A for asking a crash out on the date. The importance score is generated at the time memory object is The importance score is generated at the time memory object is created. Huh. Oh. Okay. Yeah. This is global, universe, like sort of.
It is created for every single memory.
Right.
Whoa. So remember that long list of memories we just saw?
Uh-huh.
That involves a tons of LLM calls.
You can possibly cache it, such as refrigerators. It's easily
True.
cacheable, I hope. But there's no score here. Yeah, it doesn't show the score. What do these numbers do? 23.
Yeah, I was gonna ask, like,
Oh,
duration.
I think it's duration probably.
Okay.
Yep. Okay, let's keep reading. Relevance assigns a higher memory score to objects that are related to the current situation. Okay, I think I know why they want importance, because they want kind of some sort of sanity check. A lot of times, if you just do like relevance matching, pure relevance matching, you end up still getting kind of weird things. Like you still could end up, getting brushing teeth as
Okay.
one of the top results, but you want to kind of smack that down because that's not important,
Yeah.
right? What is relevant depends on the answer to relevant to what. So a condition relevant to a query memory. I think they just keyword matching or something. If the query, for example, is that the student is discussing what is to study for a chemistry test with a classmate, memory objects about their breakfast should have low relevance. Oh yeah. In our implementation, we use the language model to generate the embedding. Oh, they actually, I'm wrong. They're actually using embedding. They're using the GPT-4 embedding.
Hmm.
Interesting. I didn't know that. Okay. Okay. We normalize recency, relevance, and importance score to the range of 0, 1 using minimax scaling. What is this? Normalize the recency, relevance score to the range using minimax scaling. The retrieval function score all memories are weighted. The combination of the three elements score equals recency factor times recency, alpha recency, importance importance times importance plus alpha relevance times relevance. Oh, alpha set to 1 hyperparameters. The top ranked memories that fit within the language model's context window are introduced in the prompt. This is rack. They invented rack.
I feel like this is smarter than RAG. They introduced, I guess they somehow populated metadatas through LM calls, even though it's expensive, but they do have a concrete measure for retrieval score.
Yeah, all RAG pipelines have some kind of ranking mechanism. If you have ranking, you have a scoring.
Right. I guess this is more like a custom scoring rather than the default similarity, cosine similarity or something.
Yeah, yeah. Okay, reflection. Okay, should we take a step back and think about how we can utilize this? Um, I think number one, at our current stage, do we need to go full rag on this?
Maybe
The
not
only
yet.
the only reason you want to go full rag is because your memory is so clogged up. There's so much noise.
Mhm.
You want to clean it up and force the characters to focus on their thinking and planning. Do we have that problem?
Memory wise, we're doing okay.
Yeah, I think so too. Okay, so we don't have that problem yet. We're not quite there yet. Reflection. Challenge generative agents Okay, I think this is more important to us right now. Generative agents, when equipped with only a raw observational memory, struggles to generalize or make inferences. Consider a scenario in which Klaus Muller is asked by the user, if you had to choose one person of those you like to spend an hour with, who would it be? With access to only observational memory, the agent simply chooses the person with whom Klaus has had the most frequent interactions, Wolfgang. Quite a sausage party. Okay. His college dorm neighbor. Oh, it's only because if you just do the simple retrieval and all that, and then all his conversation is occupied with Wolfgang,
Okay.
right? Unfortunately, Wolfgang and Klaus only ever see each other in passing and do not have deep interactions. Oh, I thought he's gonna say that he's gonna would rather spend like an hour with his crush or something. Never
Huh.
mind. A more desirable response requires that the agent generalize from the memories of Klaus spending hours on a research project to generate a higher level reflection that Klaus is passionate about research and likewise recognize Maria putting in effort into her own research, albeit in a different field, enabling a reflection that they share a common interest. What?
Interesting.
What?
So both of them are researching some fields, and
Right.
that research is a common interest. Cool.
With that approach below, with the approach below, when Klaus is asked who to spend time with, Klaus chooses Maria instead of Wolfgang. Okay, approach. We're going to look at this later after reading approach. We introduce a second type of memory, which we call a reflection. Second type, different. Reflection are higher level, more abstract thoughts generated by the agent because there are, you know what, it's kind of true. Like if you're into like learning theory and all that cognitive learning theory,
Mm-hmm.
uh, sort of reflecting, learning is some type of reflecting, kind of like a mapping and reducing in a way. You know,
Okay.
the point is reducing is indispensable because they are the type of memory. They are included alongside other observations when retrieval occurs. Thoughts. Reflections are generally generated periodically. In our implementation, we generate reflections where the sum of the importance score for the last events perceived by the agents exceeds a threshold.
Interesting.
Kind of like, okay. In practice, our agent reflected roughly 2 or 3 times a day.
So in our case, essentially, the scene, you want them to reflect a couple of times as well to see if they are making any significant progress or something like
Well,
that.
one thing I feel, if you just add some kind of inner thoughts,
Mhm.
like give them a spare sessions to compute inner thoughts,
Yeah,
spare session of the LLM to compute inner thoughts, I feel characters in itself would get a lot richer and
yeah, yeah,
complex and dynamic, like just by a hunch.
yeah. I think we can park that thoughts. Once we finish planning and reacting, we should have a decent idea on what to do.
You mean the what is planning and reacting?
Like section 4.3. So currently we're
Oh yeah, yeah, okay,
on
okay.
a reflection. We also need planning and reacting.
Okay, let's keep reading. The first step in reflection for the agent to determine what to reflect on by identifying questions that can be asked given the agent's recent experiences. Oh my god. We query the large language model with the 100 most recent records in the agent's memory stream. Klaus Muller is reading a book on gentrification. Klaus Muller is conversing with a librarian about his research project that's at the library is currently occupied, and so on and so forth. And prompt the language model. Given only the information above, what are three most salient high-level questions we can answer about the subjects in this statement? What? The model's response generates candidate questions. For example, what topic is he passionate about? What is the relationship between Klaus Muller and Maria Lopez? We use these generated questions as queries for retrieval and gather relevant memories, including other reflections for each question. Then we prompt the language model to extract insights and cite the particular records that serve as evidence for the thought. Okay. Ask questions, retrieve. Then this is like grad Q&A. Come on. Prompt language model extract insights. Okay, based on the question. Okay, here's food for thought, and then based on the question, reproduce thought. Okay. The full prompt is as follows: statements about Klaus Muller. Klaus Muller, blah blah blah. The first 100. That's a quite large context window. What 5-level insights can you infer from the above statement? Wait, I thought it's asking questions. What's going on?
So I think it has to generate the question first.
But
Giving only the information above, what are three most salient high-level questions we can answer about the statements? So it's literally trying to generate potential questions to answer.
really?
Yeah. So basically, 3 lines above the questions, giving only the information above what are three most salient high level questions we can answer.
Yeah.
The model's response generates candidate questions.
Wait.
So every
Okay. What I don't get is the information above consists only history. Or you mean history plus with insights?
this is so the questions are generated based on history. And then once you have the right questions to ask, then that's when you can generate insights.
But in here, there's no question if you see the prompt here.
Oh, really? Um, we use these generate questions as queries for retrieval and gather relevant memories. Then we prompt the language model to extract insights. Oh, so essentially all those statements you're seeing, 1, 2, 3, that's generated based on the questions asked.
Wait, why do they do that? It's so complex. Ask question, retrieve, and then retrieve, and then based on retrieve the results, generate insights. Why do they do that?
Maybe it's retrieving different things. One sec, let me just read that first. First step is to determine what to reflect on by identifying questions. We query with 100 most recent records. So you take the most recent 100 records. Based on these 100 records, you generate question. Question helps you retrieve relevant memories out of those 100.
Or interesting memories.
Sort of, yeah. But then the question would be, why can't they just use importance score or like all those scoring they did before?
Exactly. Why not?
They must have saved that score. I don't know. Maybe maybe recency importance is not applicable to all the scenarios.
Why not?
I guess,
Okay, maybe usually when we ask these questions, they answer right after. So
yeah.
let's keep reading. We parse and store the statements as a reflection in the memory stream, including pointers to the memory object that we were cited. So there's a structure. Reflection explicitly allowed agent to reflect not only on their observations but also on other reflections. Reflect on reflection. For example, the second statement about Klaus Muller about above is a reflection that Klaus previously had, not an observation from his environment. Oh, enjoys reading a book on gentrification, like this. This one.
Okay.
Reflection on reflection on reflection. Sounds familiar. Summary on summary on summary. As a result, agents generate trees of reflection. The leaf node of the tree represent the base observation, and the non-leaf node represent thoughts that become more abstract and higher level the higher up the tree they are. I think one to answer your question immediately though,
Mm-hmm.
if you talk about abstract thoughts, if you are not at the base level, and if you're at level one, which is like a bunch of memories, kind of how do you assign importance score?
Wait. What were you asking? Like, if your memory is already summarized, how do you assign importance score?
Right, right. Because those things are new kind of reflection type of memory that gets stored back into the memory.
Sure, but isn't it kind of like from 8 to 9 a.m.? Uh, Isabella completed her morning routine. So that's a one level summary, right? Level one summary. And then from 8 p.m. to 9 p.m., they were having the party. And that's a one level summary. So obviously, having a party is going to be more important than completing your morning routine. So you can
True.
still technically, I don't know why they didn't choose to do this, but we
Okay.
could try.
My question is, do we need that importance score to begin with?
Yeah.
Um. Okay. Let's look at this tree. Okay. This is the example. Okay. Observation. Klaus Muller is reading book about gentrification. Observation. Oh, this is the observation. So where does it start? This is a planning. This is his plan. And from this plan,
Hmm.
reflect the fact that Klaus Muller, arrive at the conclusion that Klaus Muller is dedicated to research, just by looking at his planning. All right. So, so you have observation. Klaus Muller is reading a book about gentrification. Klaus Muller is reading about urban design, and then we have a reflection. Klaus Muller spends many hours reading. And then based on these, Klaus Muller is making connection between the articles because library table is being used by research material. I make connection between articles. Klaus Muller is reading and taking notes on article. Klaus Muller is reading the assignment material. Library table is being used to discuss research material. Klaus Muller is engaging in research activity. This is summarized.
Yep.
And then based on all these streams coming from the lower end, you get, okay, so on this level, dedicated to research, engaging in research activities, dedicated to research, highly dedicated to research. Okay. What the heck? Okay.
Does this look a little bit weird to you? Maybe it's just a bad example, but
I hope it's actually the true example that you drew from.
yeah, yeah, I'm pretty sure it should be a true example. But why is it so research focused?
Let's take a look at Klaus Muller.
Like, does he not have a life?
Nope, that's the point.
No offense to all the PhDs, but
All right, here is okay, this is the initial state.
okay.
Innate tendency, kind, inquisitive, passionate. Learn tendency, student. I don't know what learn tendency is. I think this is still provided. He's a student at Oak Hill College studying sociology. He's passionate about social justice and loves to explore different perspectives. Currently, writing a research paper, goes to bed around 11, wakes up at 11, blah, blah, blah. I feel this is a little self-reinforcing because based on the based on the base description, we don't see that he's a dedicated researcher. We don't see that. You know, I could as well say he's a dedicated social activist.
Okay.
Do you see a researcher here? I don't see one.
Only that he's writing a research paper.
Like, passionate about social justice.
Yeah, but I guess that's why I was asking that question. It seems like all he does is doing some sort of research, but isn't his higher calling on social justice, I guess, which
Yep.
might translate into applying for internships or doing some sort of
Yep.
internship? Yeah.
Yep. Yep. I feel this is kind of I can get like the reason is because this is GPT 3, 4, 5 and
Could be.
our like Mistral, they kind of tend to kind of just converge onto something and just keep going at it,
Yeah.
right?
Like
So
now I'm really curious how long is their time span. If it's like across multiple months and that led to the final party planning, that's really impressive. But if it's only from February 13th to 14th, then it sounds more
yeah,
doable.
yeah, but we don't need something that's that consistent. I think it's just like for us, it's kind of similar. Um,
Yeah. Like
if
we
we
need
can manage to pull through a few episodes, then we're okay.
yep,
If it's a month long, my suspicion is that you gotta have a lot more fine detailed simulation of the world.
for sure.
Yeah, that's my hunch. Because you gotta simulate a lot more aspect of it in order to support this long time horizon.
Yeah.
Okay. Because I got a feeling like okay, this Valentine's party that's throwing, and then a year get past, nothing happens probably. Just like chit chat for a year,
True.
most likely.
True. That's my worry as well.
But isn't that the point? That's the matrix. That's the point. This is the point. People
Um,
going about their walking their life in a days. That's the whole point.
don't you want to have a 3-year plan or something?
No, they're not. They're NPC. They're not supposed to do this.
Oh man, I want to be an NPC.
Okay. All right. Planning and reacting. When a language model can generate plausible behavior in response to situational information, agent needs to plan over a long time horizon to ensure that their sequence of action is coherent and believable. If we prompt the language model with class background, describe the time, and ask what action he ought to take at a given moment, class would eat lunch at 12, but then again at 12:30, and then at 1 p.m., despite having already eaten his lunch twice. Optimizing for believability in the moment sacrifices believability over time. Oh wow, I think this is the best quote in this paper. I think we have that problem too.
Yeah, yeah. Okay, to overcome this, planning is essential. Okay.
Okay.
Oh, so maybe instead of planning for just the current scene, we might have to plan for another scene in advance.
Wait. I think we're conflating this. Are we talking? This is like individual characters planning. All right.
Okay.
And then we have supervisor that's sort of trying to progress the plot. I think the supervisor is doing an okay job doing that.
Oh, okay. So scratch that. So after supervisor made the new scene direction, um,
Yes.
each character has to plan.
Okay. Should we plan like we want to get them to follow the script? How do we do that?
Like you literally have to tell them to follow. So they will have to reflect on the new scene and then plan for their activities over the next 10 turns, for example.
But how does that make sense? Like things start doing things in real time. Jeremy talks to Morgan. Then Jeremy is not aware of Morgan would say what Morgan would say next. Like things change super dynamically.
They still have to plan for themselves, no? So being a prudent person like Morgan, she will try to, I guess, fix the leaking oxygen tank. And then Guy's planning will just be random exploration on different things. So they will try to do those things.
But then that sounds like intent. Like, so what's the difference between intent and planning? That's our question.
Uh, I guess technically we could use it interchangeably. Even their planning is, you can interpret that as an intent.
True. Yes. True.
Anyway, maybe I'm digressing a bit. Might as well finish reading this part.
Okay. Sorry, the live title is down. Olama 3 is acting up.
Oh.
It started generating infinite streams. Okay. I just restarted the live title. Okay. With the approach described below, Claude's afternoon plan is less gluttonous. He has lunch at Hobbs Cafe while reading at 12, works on the research paper at school. Okay, so this is like, okay, don't repeat yourself kind of thing. Plans describe a future sequence. Okay, sorry, let's keep reading. I think I get what you mean, because we try to avoid like sort of repeating yourself in a way. So you gotta have some kind of plan of action kind of thing, like or what are my goals, right? If I achieved goal 1, I check it and I move on. That
Yeah.
kind of, okay, agreed. Okay. A plan includes a location, a starting time, and duration. For instance, Klaus Müller, who is dedicating his research and has an impending deadline, may choose to spend his day working at his desk drafting his research paper. An entry in the plan might state, for example, for 180 minutes from 9 a.m., February 12th, 2023, at Oak Hill College dorm, Klaus Müller's room, desk, read, and take note for research paper. Like reflections, Plans are stored in the memory stream. Okay, plan is also memory. Reflection is memory, observation is memory, planning is all memory. And are included in the retrieval process. Interesting. This allows the agent to consider observations, reflections, and plans all together when deciding how to behave. Agents may change their plans midstream if needed. It would be unrealistic and uninteresting for an artist agent to plan on painting while sitting at a pharmacy counter for 4 hours without moving. A more desirable plan would involve the agent taking necessary time to gather materials, mix, paint, take breaks, and clean up during the 4 hour period in the home studio. I think this is relevant to us, to at least in a shorter term plan. To create such plans, our approach starts top down and then recursively generate more detail. The first step is to create a plan that outlines the day's agenda in broad strokes. To create the initial plan, we prompt the language model with the agent's summary description. Okay, this is sort of including the prompt, traits, who you are, what your experience is, and blah, blah, blah. And the summary of their previous day. Kind of similar to what we're doing, right? A full example prompt is below, which is unfinished at the bottom for the language model to complete. The name, innate traits. 𝗟𝗃𝗃 is this and that. 𝗟𝗃𝗃 enjoys taking classes, excited about new composition. On Tuesday, 𝗟𝗃 woke up, got ready. Oh, this is yesterday. Today, here's 𝗟𝗃's plan in broad strokes. Okay. Any thoughts, or should we keep reading?
Keep reading.
This generates a rough sketch of the agent's plan for a day, divided into 5 chunks. Wake up, go to Oak Hill College. Okay, broad strokes. The agent saves this plan in the memory stream and then recursively decomposes it to create finer grained actions. First, into hour-long chunks of action. 𝗟𝗃's plan on work on his music composition becomes 1 p.m. Start by brainstorming for this is so GPT. Come on, this is so GPT. Yeah. We then recursively decompose this again into 5 to 15-minute chunk. That's a lot of recursion. This process can be adjusted to match the desired granularity. Okay, reacting and updating plans. Okay. This is more relevant to us. Generative agents operate in an action loop where at each time step, they perceive the world around them, and those perceived observations are stored in their memory stream. We prompt the language model with these observations to decide whether the agent should continue with their existing plan or react. Follow the plan or react. Standing at the easel and painting, for example, might trigger observation for the easel, but this is unlikely to prompt a reaction. However, if 𝗟𝗃's father John records that he sees 𝗟𝗃 taking a short walk in the house garden, the outcome is different. The prompt is below, with agent summary description standing in for a dynamically generated paragraph-long summary of the agent's overall goals and disposition, which is described in Appendix A. It is agent summary description. It is February 13th, 2023. John Link status, back home early from work. Observation, John saw 𝗟𝗃 taking a short walk around workplace. Summary of relevant context from John's memory. Very elaborate. 𝗟𝗃 is John Link's son. 𝗟𝗃 has been working on a music composition for his class. 𝗟𝗃 likes to walk around the garden when he is thinking about listening to music. Should John, okay, this is sort of decision. Should John react to the observation, and if so, what would be an appropriate action? I think this is our turn control.
Oh, wait. John is back home early from work. John saw Eddie taking a short walk around his workplace. Why?
Wait, what's that?
Why is Eddie going to John's workplace?
Well, I don't know.
Okay.
But the point here is, this is the control part where it kind of try to decide whether to react or not, or just walk
Yeah.
by, right? For us, I guess in the future, we can use this kind of structure to decide whose turn it is to talk.
Mm-hmm.
Yeah, who would have more interesting things to say?
Yeah. Also, I wonder if we need to add an extraction layer on recent conversation or recent history. It looks like all their final reflection call or planning call is based on some level of distilled information.
True.
So we literally just put the most 100 recent history into the call and ask it to generate an insight almost.
True.
Yeah, but again, it's a trade-off
Like
between.
we can't even be more creative than this. Like we're sort of we have a different application. They are trying to simulate and keep the thing going. We're trying to create drama. Okay, so we can do something different. For example, we can say, based on the past history, derive what each character think of others. What would Morgan think about this, that, and that kind of thing? What are Morgan's thoughts? What's his opinion on this and that?
Yeah.
Okay. Okay. The context summary is generated through two prompts that retrieve memories via the query: what is observer's relationship with the observed entity? And okay. The context summary. So they separately, they actually have more prompts. Okay, they have more ARM queries. What's the relationship? What is the action status of the observed entity? And the answers summarized together. Wow, lots of summary. The output suggests that John could consider asking Eddie about his music composition project. When we then regenerate the agent's existing plan, starting from the time when the reaction takes place. Plans changed. So it's very reactive.
Yeah.
Mike, okay. Do we need only the reactive plan, or do we need we don't really need overall planning. Well, why do we need planning? Overall, long-term planning. Oh, to avoid repeated thing, like to set objective for the person, right? And then as Jeremy and Guy start talking, Morgan's plan should change.
I guess coming back to that long-term planning question, if we can set an intent through another way, we don't necessarily need the long-term plan.
What's the difference between planning and intent? I think I thought it's mostly the same thing.
Yeah, I guess what I meant to say is if each individual NPC has their own plan, like for example, Morgan might want to fix the aircraft and fly back to Earth, and Guy might want to explore a different planet. So maybe they just need their own objective And if one decides to help another, then that's a reactive objective.
Do we have that kind of granular? Like, I think we're just barely trying to get have a room, and there is like immediately maybe within the next 10 minutes what they're gonna do.
True.
But still, yeah, I think even within that short time horizon, we could try like long-term plan, reactive plan.
Yep.
Sort of the like if the oxygen tank is leaking, here is the situation. Here is Morgan, the captain. Okay. Here, what would Morgan? What's Morgan's intent / planning? Right. Plan. What's Jeremy's plan? Jeremy is a special engineer or something like that. What's Jeremy's
Yeah.
plan? And what's the guy's plan? Guy's a tourist. Okay. What's guy's plan? And then they started colliding. Okay, interacting with each other.
Yep.
And then the next problem you can do is, okay, here is Morgan's situation. Here's Morgan's original plan. Here's what just happened. What's Morgan's new thoughts, plan, intent?
Yep.
Okay. Lots of thinking. Dialogue. Agent converse as they interact with each other. We generate agents' dialogue by conditioning their utterances on their memory about each other. For example, when John initiates a conversation with Eddie, we generate John's first utterance by using his summarized memory about Eddie, and then intended reaction when he decides to ask Eddie about his composition project. Okay, I think this is not, there's too much to say. Like, here's his status, here's observation, here's the summary. Very much similar to what we're doing. Except that, yeah, again, I think their memory is a lot more concise than ours.
Yeah. More to the point.
John is asking Eddie about his music composition project. Oh, even the previous conversation is summarized. Huh. I'm kind of wondering because why they do this, because we ran into a problem where like the language model just repeat the last sentence over and over. Are they trying to avoid that problem, or there's some other consideration? Like, if you have a prompt like this, there's no way that a language model could fail. I don't think so.
True. And also, like all of their prompts are in third person while we are trying to ask the model to assume the identity.
Really? Oh yeah, you're right. Does that make a difference?
I don't know. Maybe copy that and see.
And bear in mind though, a lot has happened since the paper just was published.
True.
John wants to know more about Eddie's music. As Eddie's father, John might ask a question like this: "Hey kiddo, what's going on with the music project? How's it coming along?" Nice. Dad, I'm trying to come up with a new project. Wait, who's Eddie? Is the son, right?
Mm-hmm.
I'm trying to come up with a new melody for my song, but it's not coming together like I wanted to. I was hoping that taking a walk and clearing my head would help me get out some inspiration. Okay. Okay. Try again. I was just trying to get out of my own head and clear my thoughts, Dad. But I think I'm walking. Okay. It's kind. Oh yeah. From Eddie's perspective, John initiated the dialogue is seen as the event to which he may want to react. So just as John did, Eddie retrieves and summarizes memory about his relationship with John, as well as memory that may be related to John's last utterance in the dialogue. If Faye decides to respond, we generate Eddie's utterance using his summarized memory. Oh, actually, I take it back. They do have direct conversation.
Mm-hmm.
Okay, let me try this. How Eddie respond to John? It's all going okay, Dad. Okay, interesting. Okay. Hey, Dad, it's going well. I've been taking a walk around the garden to clear my head and get some inspiration. I'm still trying to figure out the melody and harmonies. Wow, we are better than GPT-3. Okay, if we repeat the experiment exactly, even that has value with Olama. Too
True.
long. Sandbox environment implementation. The Smallville sandbox game environment is built on the Phaser web game development framework. The visual environment sprites include, okay, this is implementation detail, JSON, and function.
Wait, maybe take a closer look at how they provide this contact information, like
What contact information?
um, context, like how we have vicinity. I'm curious to know how they're
Okay,
doing.
do they have? Oh, they don't have. They don't have.
Maybe it is section 5.
Nah, section. Then they go into evaluation and whatnot. No, from structural world environment to natural language and back again. Oh, okay. Let me actually read this.
Yeah.
The architecture of generative agents operates using natural language. Therefore, you need a mechanism to ground the agent's reasoning to the sandbox world. To achieve this, we represent the sandbox environment, areas and objects. Yeah, we need to take note of this as a tree data structure, with an edge in the tree indicating a containment relationship in the sandbox world. We convert this tree into natural language to pass the generative. Oh, interesting. For instance, stove being a child of kitchen is rendered into there is a stove in the kitchen. Hierarchy. We don't have that yet. We don't have that yet. But it's worth noting. Agents build individual tree representation of the environment as they navigate. Wow, this is important too. The environment and the perceived tree. Subgraph the overall sandbox environment tree. So there's a big tree, and then each agent, as they navigate around, there's always a subtree that follows them. We initialize each agent with an environment tree capturing the spaces and objects that agents should be aware of, the rooms and objects in their living quarter, their workspace. This is kind of reduce it to what's immediately relevant. Commonly visited store. So one thing I know, like this world is very well structured,
Mm-hmm.
top to bottom. We don't have that. We don't need to have that, but eventually we need to have that. As the agent navigates the sandbox world, they update the tree to reflect the newly perceived areas. Agents are not omniscient. Their tree may get out of date as they leave an area. Oh, wow. Okay. And it's updated when the area entered the area. Lots of memory. Wow, this is a really fine simulation. This is such a fine simulation. To determine the appropriate location for each action, we traverse the agent's stored environment tree and flatten a portion of it into natural language to prompt the language model. Recursively starting at the root of the agent's environment tree will prompt the model to find the most suitable area. For example, if Eddie's agent indicate that he should take a short walk around his workspace. Okay, high level instruction, how to translate that into grounded action in the sandbox. Currently, agent summary, blah blah blah. Agent currently in Link's family house. And the Link knows of the following areas: Link family house, Johnson Park. Okay, he knows these areas. This is his memory. Prefer to stay in the current area if the activity can be done there. Wow. He's planning to take a short walk around his workspace. Where should Eddie go? Which area should he go? And the outputs Link's family house.
Oh man, this is quite expensive.
It's free.
Yeah, still, you have to make recursive calls just to narrow down to the subspace.
Yeah, but only for each action.
Okay.
Right. In our case, we already have a call for each action. Okay, you just add I guess a new call. Let me try this. Okay. His bedroom. His bedroom. Okay. Then how do you translate this into his bedroom? Jeez. Eddie's bedroom. Okay. But it's Eddie Link's bedroom. Okay, I think we can give it like a more structured thing, like hints and whatnot.
Yeah.
Yeah, this is doable.
If you give it ABCD as the code.
Yeah, something or JSON.
Yeah.
Whatever. Okay. Control the evaluation. Oh, this is the evaluation part. I'm very interested in their ablation study, but we're out of time.
We have about 10 minutes still.
And to answer your question, I think it's pretty clear. Like, it's everything comes from the memory stream. They have this.
Yep.
That's the sort of vicinity. Like, what other question do you have in mind that's not yet answered?
Not really. I guess we just have to introduce some sort of more granular time progression.
What does that mean?
Um, so essentially, we kind of have to. So we should probably be keeping track of objects' memory as well. So, for example, if Morgan is operating the oxygen tank, then oxygen tank should have a memory stream where something was discovered by Morgan or Morgan turned it around. Um, and then next time, if Jeremy interacts with it, um,
Oh, I see. More granular, stateful things.
sort of, yeah. I don't even know if that's applicable to us, but
I think so.
yeah, I'm just seeing all the desk, bed, closet, refrigerator.
Yeah, like oxygen tank. Right now, they don't have states. To
Yeah,
begin with, they don't have states.
like for example, if somebody fixed it and it's no longer leaking, the oxygen tank itself should know it's functional again.
Yeah, I agree. I agree. The rest of the question is like, how do we sandbox them so that they're kind of grounded?
Yeah, so looks like everything is revolving around a graph. Maybe either we have Ollama builds it, or we have to supply some sort of hierarchies, spatial hierarchies.
But do we need a graph though? Because graph is like right now. Yeah, we have a very basic graph because right now everything happens in one room. Under the room, there are stuff. There
Yeah,
are objects. So it's like one level tree. You don't
yeah,
have
yeah.
to
One
be
level tree. That's what I really mean.
you don't have to be explicit about it for now.
Mhm.
You can just kind of say like, oh, they're all like we have a flat structure where there's like a list of items.
Yeah,
And what's the root? The root is the room.
this is literally like an escape room.
Oh yeah. Now I was wondering why like every time I play this I feel a little bit I have this claustrophobic kind of feeling. I think I explained it. Yeah, don't you feel like you can never escape?
Yeah,
It's always there.
like you're basically solving puzzles with everything you have at hand.
Yeah. Okay. All right. And water, more water. Give me water break 1 minute. I'll be back.
Cool.
Okay, so back to our stuff. Are we done with the paper, or do you want to read more?
I think we're pretty much done with the paper, the main ideas at least.
Yeah. Okay. So back to our stuff. Um. Oh, what's that? Okay, this is the live thing. That's kind of running. Okay, back to our stuff. So what's our plan?
Uh, so essentially, what we have right now is mostly going around supervisor.
Mm-hmm.
Um, would it be easier to go back to Miro, list down what we have in a turn, and then
The first question is: do we need to change anything? Do we just keep going with what we were doing?
the thing is, what we're doing is not working as we wanted. So perhaps we do need to change something. Let's say,
Wait, how is it not working? I don't.
um,
What's the? Because we were in the middle of implementing objects, and we kind of stopped.
oh, okay. I literally don't remember what was the outcome from last time. Maybe run it once just to refresh the memory.
We just have a whole bunch of bug we need to fix. To be honest,
Ooh, okay. Are those easy to fix?
I'm not sure. I haven't run this for a while myself, so that's tough. Server. Oh, but, oh no. We're not constructing the world very properly. We're doing it like in a Scrum Agile style.
Right.
Yeah, yeah, all these errors and stuff. Actually, this is sorry, my bad. This is me trying to convert everything to Llama 3.
Do
Not
you
Llama
have
3.
pull the latest changes? Oh,
I'm at the latest.
okay.
Yeah, I just stashed all my Llama 3 uh, fancy things. Oh, this is quite nice. But why is everything pink? Okay, let's see. Make it generate one rounded things. Okay, start generating. I think our visualization is quite nice, actually.
Yeah. Um, right. So one thing you have to fix is all those props. Um, I feel like instead of showing LM all the props, maybe we should be showing the latest reflection of each prop.
What is a reflection of props?
So if we have an object saying Morgan, it should be the latest, um, I guess, the latest important memories. For example, Morgan just discovered the oxygen tank leaking.
Oh, kind of
Um,
like state.
yes.
Okay.
So that's one thing.
But
Uh,
then, okay, okay. Let's take a look at the problems first. Like, what problem do we have right
uh, I actually don't know if they're
now?
piercing or not.
Okay, time to use the data tray. Yeah.
Nice.
Oh yes. Oh no.
Uh,
What's this?
at, at is not a constructor. What is this map controls?
Oh no. What's this? No. Oh, okay. They kind of failed as expected.
Okay. Um,
Let's see the error in here.
must be array. Oh,
Coming from
I thought we fixed that dot dot dot.
character worker to summary worker.
Placeholder.
Did we?
Oh, maybe just change it into an array. That's an easy fix.
So no actions.
Yeah.
Uh,
Unless you wanna throw an error here.
but okay. Let's see. Like the bigger problem is how did it fail to parse? In what circumstances will it return now? What?
So instead of returning an array of actions, it returned an object which contains message.
That's the problem. But then it should have been called by the previous step. Okay, let's try. Let's see the tree of this. This is so nice. This is so nice. This comes from here. Ooh. Oh, thank you. We have prompt here too. This is quite nice. This is nice. Okay, we have this. From turn to action character. From turn control to character worker, from character to default to summary worker.
Yeah.
You are a helpful assistant. Why does it still say vicinity? Oh. Character name, photo, vicinity information, allowed actions. Character name, Jeremy. Did we fix this? I thought we fixed this.
Same. It,
Oh, did we save it into the branch or something?
yes. Our changes are in a branch,
Really? Really?
which might be broken. Multi actions.
Okay. Do it again. Yeah, this is sort of like the previous generation.
I don't even know if this branch will work though.
Nope. Because
This branch might needs to be synced.
yeah. Okay. gRPC error.
Uh,
Interesting. Why is that?
oh, it's you're not trying to access local vault in Cloud Dashboard, right? Just don't open that file on the screen.
Thank you. What's about?
Yeah. That was very stupid of me.
No, it's not local. But then remote should still work. I'm very confused. Why is it not working?
Was it the global project ID issue again?
No. Call cancel. Like it's got to be some error in this branch because
Oh, did you do yarn? Um, like yarn post install and stuff?
yeah, this feels super outdated. Oh yeah. The environment is not created properly and all that. I think there's a global environment is even not set up properly.
Hmm.
Okay, let me close this and reopen this. Just give you a second to so I load the typing and all that. Okay, try run this again. Oh, I think we made some changes to the main. Should we merge those changes back?
Yeah, I thought you did.
Okay. Wow, a lot was changed. Okay.
Mostly front end.
I think there's some backend stuff as well here. Oh, local server is not running. Hold on. I'm just gonna use the remote because remote is up to date.
Okay.
Yep. I don't know why, but for whatever reason.
Hey, what's that? Well, if
I think yeah, I remember it's stuck at like a summarizing or something like that because our summarizer is outdated.
yeah. Uh, I thought we now put talk as one of the actions. Is it just the console log that's printing message separately?
Yeah, I think this
Okay.
this gets restructured and all that
Okay. Okay.
because we're sort of in the middle of old and new and summary.
Mhm.
I think game state still uses the old, but the individual character, the actions that's produced in character is a new kind of format.
Okay.
Okay, let's take a look at the data chain. Okay, right now. Nice. Wow. Okay. Wow. Oh. Ooh. Okay. I was in the middle of doing this zooming in and zooming out.
Mm-hmm.
And then I ran into an issue. I think we need to by the way, we need to change the way the anchor point is calculated.
Okay.
But yeah, hold Hold on. Yeah, this is the very beginning. It's still going.
Nice.
Okay, let's take a look at what they generate. Okay. This is the starting state. Hey, what's that? Okay, this is what we give it. Now it goes into the summary worker. Oh, this is from the character worker.
Yeah, this is what the character worker generated.
So what it did is operate a life former and walk to the mysterious cave. Well, if it's an otherworldly jungle here, and I thought the life form detector would finally shut up for a minute. I thought we introduced intent. No, there's no intent here.
Not yet.
Oh, look, a mysterious cave calling out to us. Just like an old-timey adventure story. Let's see what secrets it holds. And then from character to summary, and from turn control to character. This is kind of weird. And then from supervisor to turn control. Okay, it does all these like a dance thing, and then finally turn control to character. Yeah, there's a lot of these like states that gets passed around. Supervisor to turn control. Wait, what? Is this supposed to be the loop? Okay, character. Are we outputting the prompt? Or we're not?
No.
Wow, this jungle asks something else, and then examine. This cave is quite interesting. I should examine it carefully. And there's Morgan. And then this is Jeremy. All right, let's see what secrets this mystery holds. After that, we can explore the intriguing giant tree. Okay, they kind of keep doing this thing over and over. That's our problem, right? So go through a bunch of turn control supervisor, turn control the character, and then Morgan. The cave holds a certain charm that piques my yeah. They don't continue. Right. That was our problem. They just I'm wondering, and we still got that problem.
Okay. By the way, can you just quickly go back to the code? I thought we added something about intent in the few shot. Do we
save it? No, probably not.
like
Wait, the
where
character, right?
actual prompts? Wait, hold on. Is this the latest version?
I don't know.
Did I not push?
I don't know.
Okay, I remember, unless we didn't get a chance to finish updating it, I remember we said something about removing messages.
Oh yeah, what's going on here? This looks like the older version. What's going on?
Yeah, this is very weird. Wait, do you have a feature called feature/prompt?
Nope. I don't.
Oh. Okay, so I never pushed that branch. Shoot. But I'm pretty sure the new feature prompt branch is broken. Let me just do a couple of things quickly.
The visualization is great. This is so good.
Okay, so if you do get, you should be able to find the branch called feature/prompt.
What do I do? Just merge it?
Uh,
Or
you can ignore multi actions. I think that was an obsolete branch.
okay, then let me do a sync with the main again.
Yeah.
Oh, it's quite new actually. Everything is in sync. Oh, it's brand new. Okay. Do I do I need to do YAR? I don't. Yeah, I don't think so.
Yeah, I'm pretty sure this one is going to be broken.
Oh, so no, this is break.
Yeah, like this is the
No,
one we were trying to add in intent and objectives
it says no data. What's going
because it broke on the first one, I'm assuming.
on? And still,
It's,
there
it's
needs.
not completely fixed.
Okay, so what's it complaining about? Validation failed.
Yeah, because this is the one where we removed message as a separate field and we haven't updated the test case and everything yet.
Okay, but I shouldn't. Oh yeah, it's actually catching this in here. So recent history, the initial state is wrong.
Right.
Okay, so recent history has become subject, and then wait, what? How can recent history become this subject?
Yeah,
Reflection.
we restructured it.
Yeah, this is not right. This is recent history is an array of this.
Yeah. So subject
But I think we
reflection.
talked about we don't need a reflection intent in real history, right? Or do we?
Don't we wanna uh don't we want
A reason. That's a lot of stuff.
that's the prompt we tried. If you look at the test case, um we iteratively added reflection intent.
Right, but that's to help the LM think. It doesn't need to be part of the history.
Um so
Maybe
you mean that will be stored as a local memory. It doesn't have to be passed around
I like.
between.
I think last time like the intention was just to discard it.
Okay.
But okay, let's try this. Okay, maybe this works very well. It's a tourist. Okay, action. Intent. Sure. Okay. This is so messy.
Yeah, like do we even want to bother fixing it? Or maybe we can just implement whatever we want from the paper. Let's
I
say,
mean, I mean, we already taken quite a bit of things from the paper just for this
okay,
already. Uh, reading the paper is just really trying to either change, realign, or affirm what we're doing.
So how are we getting reflection intent updated each time?
You generate alongside actions.
Really? Is that
That's the simplest thing, minimal thing you do, and
no, but is that done at the moment?
I think so. Why?
Uh, I guess I just don't remember implementing that part.
Okay, let's check. Jeremy, wait, is this from before?
Is that the same project ID?
Yeah, it is. But it should automatically pick the latest round.
Okay, so all of the intent
Oh yeah,
and
it has a reflection. It has a reflection.
right as an empty field.
Wait, did we not? Wait, what? Did we not implement the reflection?
That's what I remembered. We didn't add in the prompt for that.
Okay, let me check. Okay. Inside a character worker. So intent, where does intent come from? There's no intent. So,
Do a global search maybe.
sorry?
Do a global search. It might be in Gen action prompt.
Yeah, it has intent.
So this is a few shot example.
Right. It has intent. It has a reason. It has
Okay,
reflection.
so it is. I guess it should be trying to generate
It
these.
should. It should. I think.
But when we parse the actions, do we wait? What is this?
One of the many bugs.
Yeah. Like remember we had a parse action prompt and
Oh, look at that.
what?
What? Bookshelf, computer, clock, stack of paper?
So instead of having a single target, it's trying to examine an array of targets.
Okay. I don't know what's going on. Let's go to the very beginning. Oh, this is so nice. Okay. Okay.
But take a look at parse JSON actions. Like it's trying to return response.actions. Is it? Right. Response JSON.actions. But your intent and objective are part of that JSON object.
I see.
Yeah, I think that's where I stopped last time. Um,
I
so,
see.
so we'll have to preserve like intent and objective.
Well, if you do that way, like, then you kind of need to flatten. This is sort of like actions grouped by intent.
Mm-hmm. So one thing you can do is probably map out, like replicate replicate the intent into each action object.
Alternatively, though, how about in recent history, I introduced a new type of thing that's called thinking.
I think that's what we try to do in few shot, like having.
No. I mean, in recent history,
Okay.
uh, recent history right now has where is that defined? Game state schema. Recent history, subject, relaxing, intent, action, reason.
Mm-hmm.
Instead of doing that, we do. You can be either this. Let me change this slide slightly. This is not action schema. You can do either like this.
Yeah. Yeah, we could
So
do
that
it.
if you do that, you don't need to repeat yourself. Just throw the thinking, like it just kind of intertwine them, like just like insert thought, action, 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 then thought, action, action, action.
Okay.
Does that work?
My only concern would be the LLM is not gonna be smart enough, like to handle two different kinds of schema. Like
This is
right
only,
now,
this is only input. This is what you store in the recent history.
Okay.
This is only input, like for character workers, and that we already have character workers. It's working,
Okay.
right?
Right. I guess I'm just thinking when you're passing those along, does each of those character workers, supervisor worker, summary worker do validation on the typing?
Yes. Everything validates is validated by game schema,
Right.
game state schema.
Okay. I think let's try. Should be okay.
Thought is, I think thought is just intent, you know?
Sure.
Thought.
Yeah, thought is just reflection.
Okay, let's just make two things. We have a lot of things: reason, thought. I think we don't need reason. Do we need reason?
The only reason we had reason is LM is trying to justify.
Oh, okay.
Yeah.
Oh, actually, instead, let me think. Yeah, let me just make it slightly easier instead of actions. Oh no, actions and thoughts. Oh wait, this is already formatted into this, so it doesn't need to repeat, right?
Isn't this what we started with?
Yeah. Okay. I was being stupid. Oh, we already wait. We don't have this. Wait, what?
So,
Yeah,
like,
I was saying we need to group this, but this is where we start. Okay. Yeah, this is good as is. I think. Don't need flat. Yeah, we don't need this. We don't need to flatten this up. Like, and we can't just do that. Okay, we're back.
Cool.
Just need to refresh the cache. Okay.
Yeah.
Okay.
And before we resume, I guess just doing a bit of time check. How?
Oh, 10:30. Okay.
Or,
We got to finish this now today.
okay.
But then, okay, I'm trying to understand.
Yeah.
This as is, so what's the problem with this?
So the problem is we haven't properly passed around intent and objective yet. So that's caused by parse JSON schema, where we are only returning.
Oh, here.
Yeah, we are only
Oh,
returning actions.
okay. Time check. Then,
Oh my gosh, I can't believe I literally added to do there.
okay, good call. Okay, then, because as you parse, it's not taken out. Okay, I see. Let me check my time real quick. $10?
Sure.
Okay, let's try it. Let's see if we can finish this. Uh, you were saying.
So this needs to include.
Can we do like z.infer or something? Yeah, like that.
Yeah. Yep.
And return.
It shouldn't be dot actions.
Return.
So now it's basically returning an object rather than.
Yeah. And then in case of error, what do we do?
That's why the to do, because so we
throw.
still.
For
Sure.
And then parse response JSON. Yeah, this doesn't exist. Parse JSON response. Okay.
But still, you can't just pass out actions from character worker. You have to pass out intent and objective as well.
Weird. This doesn't have a.
Type of character. Oh, character input schema hasn't been updated yet. So this should be that.
It's not input. Is it input?
Well, technically,
What kind of schema is this using? What?
It might be just terrible naming. We can call it. Maybe we can call it actions intent objective schema.
It's just character output. I think
Sure.
character.
Yeah.
How should we change it?
So now this should include intent and objective as well. Maybe we can wrap that all in one object.
called subject, right?
Okay.
Reflection, intent, and actions. The action schema is did I just change that?
Action schema should be fine. Yeah.
It should be like this. Yeah.
Okay.
Action schema character. Okay. And then back to the character worker. R now. This action, yeah, this is not correct.
I guess technically you don't even need to reassign actions anymore. I don't even understand why that needs to be like action null.
Wait, which part?
Like this part, if not action, then
Yeah, okay. I think it should just be able to pass it right through
I hope so.
like this.
Yeah.
Okay, what else is wrong? In here, this is the summary worker. Okay, actions, subject, from doesn't exist anymore.
Yeah.
Subject, and then
Subject, reflection, intent should all be there. And then you can even remove that const label equals object. Yeah, subject can just be subject. It doesn't have to be label.
no. Okay. Should
Cool.
be good, right? Yeah, Smallville should just work.
I guess that's a good thing about having typing control.
Oh yeah. Oh yeah. Wait, what? 540
4 years ago?
something definitely is not right. And I don't know what happened.
Is it having trouble provisioning the resource?
Yeah, something like that probably.
Yeah, this conversation workflow doesn't have a random ID.
You don't need it for most of the time. You shouldn't need it. Okay, this is provision. Job started. Nothing happens. Okay, I put in the initial input. Where do I put it? I put into summary supervision. Is it running?
No, it's definitely not running. It's the provision issue.
No, the job started. Everything's fine.
Yes, it does say job started, but if you look at your Vault output, it's gonna say something like requesting queuing 1 while capacity 0. That's the error message I sent in dev channel the other day. Not exactly an error message, just logging.
But if job started, it means job started locally.
I don't know why job started would show up there.
That literally means like job has started. It started working. It's okay. Yeah, attempt to increase by 1. That's the correct message.
Right, attempting to increase by 1. It hasn't increased to 1 yet.
If it's not increased, then job will not start.
but it hasn't increased to 1. Maybe that drop started.
It increased by 1 and increased to 2. It is correct. The message is correct.
Maybe the place where it drops. Oh, this time it's working. Okay.
No, the other time it shouldn't. It's not that problem. I don't think that's a problem.
Okay.
All right, what do we have now? What?
That's the thing. It always. So I think we had reason in our few shot.
Okay,
If we don't have reason there, it's gonna try to add reason.
yeah. Okay.
So might as well we just proactively add reason.
Or I just get rid of reason. Hold on. Yeah, I
Remember?
don't want to overwhelm the LM with just so much stuff. Hold on.
Yeah.
So character worker, you respond, and then I'm gonna do. Yeah, like that.
Okay. Is Lodash already part of package.json?
I use it so often. I assume I have already installed it somewhere.
Okay.
Or maybe not. No. Nope. It's part of Vault client. That's why it's included through a very strange chain of dependency. This is the first time it ever worked like the new version. Okay, let's check. Okay, go straight to the data chain, our favorite view.
Something else though, when we construct the new prompt, do we actually map intent and objective to the new inst?
What problem are you talking about? Like
So
the
um so when we construct the actual prompt,
the prompt for the character?
yeah, I think it's called gen action prompt.
Oh yeah, maybe not. I see. This one doesn't have intent in it. Oh yeah, it does.
Right, the few shot examples definitely have intent and reflection. Yes. So you see objective colon line 262, it didn't have like action dot uh, intent or objective.
Yeah. Okay. What do we do then? Dot flat map this and then dot map or what?
Shouldn't it be objective line 262, not part of recent activity log?
Wait. Okay. So what do I do?
Line 262, do you see line?
I actually don't know how a flat map works. Okay.
No. I mean, it's not in recent activity log section. Go back to line 262. You see objective colon. This is where,
Yeah.
yeah.
Oh, wait. But I thought intent is generated on the fly. Intent is generated on the fly.
Oh, never mind.
One
That's
call.
a different issue. How do we define the overall objective?
Oh, so we don't have that yet, right?
Yeah, we don't have that yet.
Okay.
That's another thing we need to figure out. But for now,
Well, it keeps running.
I guess that's fine. As long as the validation passed, there's no reason it won't run.
Okay. So let's check. Okay. Do a close. I never can we like like take a look at it. What is going on so closely? Okay. Then prompt. You are a helpful assistant. Determine the next action. The subject. Okay. Prompt. Subject allowed. The subject. Okay. This is a fuchsia. Objects in scene. Morgan. Blah blah blah. Okay. Then this is the output. Jerry wants to investigate the cave. Action. Walk. Hey Morgan. What do you think is there? Let's find out. Action. Talk. Reflection. He should We should explore the mysterious cave to find out what's inside. Maybe okay. Maybe yeah. Maybe we need to take these into two steps. Maybe divide them into two steps. Probably. For so far, okay. Okay. Summary to supervisor. Yeah. These are like just passing through. Summary to super. Okay. Here. Why? Why does it come out from? This is weird. This should come from character worker. Oh yeah, it is come from the character. Okay, never mind. Okay, I must use my skills to aid the team to examine the surroundings. Hey guys, let's use a life form detector to see if there's any creature indicated. It's very helpful. Okay. And then go to this, and then it's whose turn? Morgan. Yeah, I think they're stuck again.
Yeah.
Hey team, let's cautiously proceed.
Yeah.
Get out of this shit. Oh
Now
man.
I remember the reason we started looking at that paper is to figure out how do we handle objective or
Get
intent.
out of the hellhole. Okay, so what do you suggest? Okay, let's follow Morgan into the cave, guys. Okay, then you have a point. State must be changed. Do we agree that's the number one issue right now?
Yeah. I think this made the issue more obvious. By the way, is this kind of linkage correct? Like from character 32C, that's supposed to be coming from two parents?
Yeah, character has more than one, I think. It looks correct to me.
Okay.
Let's double check. Has more than one input. Live game 1 6 minutes ago. Character has has user input. Has default. Oh, character. Oh, right. Yeah, this is it has to either reflect as such. So
We return the standalone data point ID on the left, that's returning the prompt. So we can
right,
visualize the prompt.
right.
Ooh, nice.
This is the output from this is supposedly character worker node, but it's kind of weird.
Yeah.
Like default, and then spits out these two things. It's kind of little confusing, but doesn't affect our ability to wait. Why does it branch out into two? Oh, it's probably supervisor at work. Yeah, this is supervisor. Character. Okay, this will have a. It's weird. Supervisor kicks in. What did the supervisor do? Scene 1, recent history. What did the supervisor do exactly? We can take a closer look at that next time. And that doesn't seem like it's doing anything. Supervisor, character worker to summary worker. Let's see what's inside. Yeah. Please proceed. Wait, what's and then we have a little. Do you see this?
Yeah, it's duplicated.
Not really overlap each other.
Yeah,
from the-
overlapped. Yeah.
Do you know why?
Uh, it's so both of those nodes are trying to calculate their position based on the parent. So because they're calculated at the same time and they only have one parent, then their derived position is going to be the same.
Okay.
So that's expected, but it's a problem.
Okay, we talk. Oh wait, why is why do they do this thing again?
I think it will be better if you, like in your URL, copy paste the 𝗪𝗶𝘃𝗲. If these are constructed initially, then the position will be fine.
Well, okay, but it still is a problem. Okay, we'll talk about that later.
Yeah.
Okay, I cannot see what's behind this. It's the character.
Yeah.
Oh, so we cannot see it right now. Okay, let's see what's the end error. What the heck?
What?
From character worker to software worker, and added a dramatic twist.
Okay. Another thing we need to figure out is how can we allow these additional properties to pass through? They don't really affect functionality. It's not like it's missing a required schema.
Okay. Okay. Next time we agree. Change object state.
Yeah.
But design object state.
Yeah. Like whether we do it in one go or we figure out the objective first.
Okay.
And then, yeah.
Okay. Cool.
Cool.
Okay, let's end the live stream now. So it's overtime already.
All right.
Bye. Next time.